Okay, USC has a big football game Saturday night. I know it'll already be over by the time you watch this video, but they play Boston College tonight at 8 o'clock, so watch it on ESPN. Okay, I'm going to continue here with the next video. We're going to finish up the wetlands and hit the ocean. Let's do this. Here are some of those other wetlands that are mentioned here in the book for you. First, we have salt marshes. We've got a nice picture of that. Mangroves are pretty interesting. And then I got pictures to go over with you of intertidal zones and coral reefs. So let's use the pictures to tell the story. First, salt marshes. And you can tell a salt marsh is much like a normal marsh. It's got grasslands, not trees. Of course, the difference is they are the wetlands right along the ocean. And of course, all of our marshes around here are salt marshes because the water that's in the salt marsh is salt water. This is a good picture of what mangroves look like. If you've ever been down to Key West, there's a lot of really cool mangroves down there. I once went down and rented a little 19-foot fishing boat, and all we did was drive around all these different mangroves. Look at the unique feature of the trees, and this is what makes a mangrove and not a swamp. It's that these root structures actually grow up out of the water. Now, it's rooted in the water, obviously, but mangroves have this very characteristic viewpoint of trees that actually have their root systems way up out of the ground. And you can imagine the reason that we talk about this as a separate biome is because of many of the unique animals and plants that have a tendency to grow inside of this protected, like a cage, this protected area where all of the root structure of the trees are. Very, very unique biome, the mangrove. Here's another picture. And again, like I said, these trees whose root systems are growing up out of the water. That is a mangrove. I have this picture in here to show you the intertidal zone. Now, inter means between, and of course we have tidal, so you can guess what the intertidal zone is. It's the land between tides. It's underwater at high tide, and it's above water at low tide. Intertidal zones can vary a great deal. I think in another chapter I've actually got a picture of a high tide and low tide in the Bay of Fundy up in Canada. Their daily tidal difference is like 50 feet. You know, for us around here it's like, what, 4 feet, maybe not even 4 feet of intertidal zone around here. But in certain areas of the world, the intertidal zone is very, very large. Very large. Anyway, this is another ecotone, right? So you can tell that there are animals that live in the water most of the time. Here they are on land because the tide went out. But when the tide comes back in, these guys will be underwater again. There aren't all that many species that can exist both in land and in water, because most species that live in water are designed to get their oxygen from dissolved oxygen that's in water, like the gills of a fish, for instance. There are some fish that actually have a primitive set of lungs. They're called lungfish. What a surprise. And the lungfish can live on the land for 5 to 7 hours, something like that. They can actually live in the intertidal zone because they have a primitive set of lungs. And starfish have the ability to go long periods of time without their oxygen from the water, so they can survive in the intertidal zone. The coral reef is another fantastic biome, and of course the coral reef is a biome in the ocean. So let's talk about what the coral reef is made up of. Millions and millions of dead coral. Coral is actually a soft-bodied, squishy tiny little organism with little stinging cells on the end of it, because the coral reef the coral belongs to the same group of animals as jellyfish. So they have these little stinging cells on them. And so the very outer part of the coral reef is composed of living coral. Now, in order for coral to survive with that soft body, they secrete calcium carbonate and make themselves a little shell. And that's what the coral reef is made of. Millions and millions of dead coral over thousands and thousands of years, and that hardened calcium carbonate shell has built up and actually formed an infrastructure. It's actually formed a building. And so this area of the ocean, right along many of our coastlines, has high biodiversity. There's more different kinds of organisms at the coral reef than any of these other biomes that I've mentioned to you today. Now, you know, the coral reef, it's like illegal to touch coral because we don't want to be breaking up that calcium carbonate deposit that makes the backbone, the skeleton of the coral reef. Because if that part of the reef is destroyed or goes away, well, then there's that much less area for all of these different fish and all the other plant life to be able to survive. And the other thing is, you can actually sting yourself touching a coral reef. A lot of the coral reefs around the world, they don't have laws against touching them, and people do touch them and they get stung. Now, it's not a sting like a jellyfish sting because these organisms are tiny, but you do get a stinging sensation when you touch them. The other big issue with coral reef is because it's so close to land, anything that we do that affects rivers, anything that we do that affects coastlines has an effect on the coral reef. So if a river is heavily polluted and there's a coral reef 20 miles out from the mouth of that river, that pollution can make its way to the coral reef and kill organisms. So we are concerned with human activities when it comes to river pollution and our coral reefs. We're also concerned about something called coral bleaching. And the reason it's called bleaching is because you kind of lose that coloring, that beautiful coloring of the typical coral reef. The algae that are important in this food chain begin to die, and without the algae, the reef begins to turn white. There's two big problems with coral bleaching. pH changes, and remember what I told you the other day, don't ever forget, just small changes in pH have a devastating effect on living things. They cannot handle changes in pH. So a lowering of the ocean pH, like we've talked about in the carbon cycle, that carbonic acid that's formed is causing coral bleaching to occur, and also abnormally high water temperatures. So those are the two things causing the bleaching to occur. I believe we'll have more on a coral reef in another chapter when we talk about water pollution. I think that's about all I need to tell you about the reef. So let's talk about one last area, one last biome to talk about, and that is the open ocean. And here are the things that you need to learn about the open ocean. Once again, I have videos to show you that are pretty interesting, or at least informative, about the open oceans, but I'll save those for class if you remind me to show them to you. Alright, so here's the words you need to be looking out for when it comes to the open oceans. The photic zone, the aphotic zone, chemosynthesis, and of course we've already kind of mentioned tides and the tidal area. Alright, so the intertidal zone we've talked about before. It's the area between high tide and low tide. It's underwater part of the time. Then you've got the surface area of the water, and this is called the photic zone. What's photo in front of anything mean? Light. So you're correct if you thought that the photic zone was that area of the ocean in which the sun's rays can penetrate. There's lots of living things that live in the photic zone. Lots of living. So this is where all the fish live. This is where all of the marine mammals live. They all live in the photic zone. They don't go down below which it's too dark to see a thing. And that's down about 200 meters, which, by the way, is, it's what? About 600 feet, something like that. I mean, that would be a deep dive if you were scuba diving, to go so deep as to be down 200 meters. Well, below that then we have is the aphotic zone. A in front of anything means not. So it's the not light zone. So it's the area that's completely pitch black down deep in the ocean. The benthic zone, just like the benthos that we talked about in a lake, the benthic zone is the area at the very, very bottom. It is the ocean bottom. All right, and that includes here. All right, even though this is rather shallow, the muck and the mud where all the decomposers happen, that's the benthic zone. But down deep in the ocean, that benthic zone is really, really full of decomposers, because after all, where's all the things that live in the ocean go to die? The bottom. And so they end up falling down here. All that dead material has decomposers loving life. All right, in the aphotic zone, you got to remember something. We have not been to the deepest parts of our oceans. You know, here you see some almost volcanic type activity that's occurring down here at the bottom. There are places all in the Pacific Ocean that we have not been. The depth is too great. We have not created a steel container or whatever, a submarine or even a camera that can stand the pressures of that depth of water. So we don't know what's down there. Every now and then we come up with some new material, or we engineer a better camera or a better submarine, and we get a little deeper than we used to be. And we discover some funky looking fish down there. Right? We actually have fish that we've discovered just in the last 15 years or so that have bioluminescence. They actually can create their own life. Or light, I'm sorry. So the question gets to be, how can there be anything living below where the sun shines? If there's no sun, how do they get their glucose? There's no photosynthesis. Well, the answer to that question is, we have discovered species that do something called chemosynthesis. All right, it's just like photosynthesis. It's the production of glucose without light. Chemosynthesis. They are producing their glucose chemically, and so that's where we get that word from. So chemosynthesis is without the presence of light. Photosynthesis, of course, is with light. And I think I've hit all of the different aspects of the water biomes that I wanted to. I know that there will be a couple of things in these videos that I need to hit upon, and I'll do that as the video shows. So we got some short, sweet videos and lots of discussion when you come to class tomorrow. How about that? That, by the way, boys and girls, is the end of Chapter 4. You might be ready to answer some questions at the end of the chapter. You might be thinking about taking a look at the yellow boxes at the end of each chapter and seeing the major concepts, the major ideas that are presented in this chapter. All right, I'll see you later. Bye-bye.